the materials. Prepare 2 empty bottles and label the first bottle with yeast and the second bottle without yeast. Put 2 teaspoonfuls of sugar to each of the bottles. Put also 3 teaspoonfuls of dry yeast to the bottle with a label of with yeast. Slowly pour the warm water to the 2 bottles. Put a balloon over each of the bottle and wait for half an hour. Catalysts are the unsung heroes of the chemical reactions that make human society tick. A catalyst is some material that speeds up chemical reactions. With a helping hand from a catalyst, molecules that might take years to interact can now do in seconds. Yeast is an organism that contains a special chemical called catalase, and it can act as a catalyst to help break down hydrogen peroxide. Catalase is present in almost all living things that are exposed to oxygen, and it helps them break down naturally occurring hydrogen peroxide. As the yeast feeds on the sugar, it produces carbon dioxide. With no place to go but up, this gas slowly fills the balloon. Here are the materials. Soak a matchstick in a water at room temperature for 1 minute. Place the matchstick over a lighted candle enough to light it and observe the intensity or color of the lighted matchstick. Soak a matchstick in an ice water for 1 minute. Place the matchstick over a lighted candle enough to light it and observe the intensity or color of the lighted matchstick. Chemical reactions are everywhere around you and inside you. In addition to the biochemical reactions that allow you to transform the molecules you eat and breathe into usable energy, there are industrial laboratories in cities around the world producing chemicals as well as products that rely on chemicals for their manufacture. One of the most important aspects of a reaction, in addition to the product or products produced and having a proper supply of reactants, is how quickly a reaction can be expected to proceed. The effect of temperature on rate of reaction can have a tremendous impact. In my experiment, the rate of reactions in tap water is faster than in cold water. It is because when the temperature of a solution increases, the molecular energy levels also increases, causing the reaction to proceed faster. An increase in temperature typically increases the rate of reaction. An increase in temperature will raise the average kinetic energy of the reactant molecules. Therefore, a greater proportion of molecules will have the minimum energy necessary for an effective collision.